The software development cycle. Software engineering is the study of designing, developing, and maintaining software. The software engineer oversees the life cycle of software development, including the initiation of the project, analysis of the specifications, and design of the program, as well as implementation, testing, and maintenance of the final project. Margaret Hamilton, a computer scientist who helped develop the onboard flight software for the Apollo space program, coined the phrase software engineering. Her code prevented an abort of a moon landing. There isn't just one correct way to design a computer program. How you write the program depends on the application, and there are several different software development models, including prototyping, incremental development, rapid application development, agile software development, and the waterfall model. We will go over each one of these software development models, beginning with prototyping. With prototyping, an application of a final system is built, tested, and reworked until it is acceptable. The complete system is then developed from the prototype. Incremental development. The software is designed, implemented, and tested a little bit at a time until the product is finished. Rapid application development. The user is actively involved in the evaluation of the product, and modifications are made immediately as problems are found. Radical changes in the system are likely at any moment in the process. Agile software development. The developers offer frequent releases of software to the customer, and new requirements are generated by the users. Short development cycles are common in this type of development. Waterfall model. The process of development is sequential and flows downward, like a waterfall. The waterfall model of software development came about in the 1960s in order to bring structure and efficiency into the process of creating large programs. The steps of the waterfall model include conception, initiation, analysis, design, construction, testing, implementation, and maintenance. So what's the best model? Well, it depends on the situation. It varies from problem to problem, situation to situation, and even company to company. You should view the models of software engineering as tools in a toolbox, in which the techniques that you apply depends on the project you are working on. Program specifications. The program specifications are delivered from the design team and are not written by the programmer. The specifications, or the descriptions of the program, should indicate what the program will look like, how it should operate, and what it should accomplish. The specifications are written descriptions of the project, and typically the specs are based on the customer's requirements. The first step in writing a program is to analyze the specifications, make sure you understand them, and clarify what the customer or design team has in mind if you're unclear about anything. Great programmers have good communication skills, so they can talk back and forth with the person who writes the specs to clarify any questions they may have. Program design. Detailed plans for solving problems are outlined in the specifications. Program design includes objects that will be used in the solution, data structures that will implement the design, detailed lists of tasks to be performed by the program. A good design provides a fairly detailed overall plan at a glance, without including the Java code. Program implementation. This is where the actual coding occurs. Testing and debugging. And there are three areas involved in testing and debugging, starting with test data. Typical data values in each part of the domain of the program are introduced to test the program. Types of errors, also known as bugs, include compile time errors, runtime errors, and intent or logic errors. A compile time error is where the compiler is unable to translate the program into bytecode and prints an appropriate error message. A syntax error is a compile time error caused by violating the rules of the programming language. Runtime errors occur during execution of the program. The Java runtime environment throws an exception, which means that it stops execution and prints an error message. Typical causes of runtime errors include attempting to divide an integer by 0. Intent or logic error is one that fails to carry out the specification of the program. And then the third area is robustness. The program doesn't give inaccurate answers for some input data. It doesn't crash if the input data are invalid. It doesn't allow execution to proceed if invalid data are entered. And program maintenance. Upgrading the code as circumstances change and adding new features. Because new people will be added to projects, original programs must be clear and contain precise documentation.